I am Julia LAMAS and I'm going to present steam-enhanced gasification of a hybrid blend composed of municipal solid waste and torrefied biomass, a work done with Professor EDGAR Silveira. The final work was already and recently published in August of this year at the 30th European Biomass Conference and Exhibition Proceedings. Waste-to-energy technologies are used for energy recovery through thermochemical conversion and have become an attractive alternative to high energy demand and waste mitigation. Woody residues and municipal solid waste can be used in hybrid biofuel, mainly in growing cities such as Brasilia in Brazil. This work aims to implement a multi-criteria decision method to identify the optimal operating conditions of gasification for a hybrid blend of MSW, raw, and torrefied biomass. First, bibliographic analysis helped to determine the proportion and components of the blends. Next, woody blends and torrefied ones were prepared and composed of 6 different urban woody residues. MSW comprised 35% decomposed organic waste, 30% paper, and 15% plastic. A multi-criteria study provided the best operational condition and the optimized hybrid blend. To sum up, the blends were subjected to the gasification modeling with 3 atmospheres of air, steam to biomass of 0.25 and 0.5 at a temperature range of 600 and 1000 degrees. Finally, the multi-criteria study provided the best operational condition and the optimized hybrid blend. As results, the hydrogen-CO ratio decreased for higher gasification temperatures and increased for higher steam-to-biomass considering raw and torrefied blends. Both lower heating veil (LHV) and cold gas efficiency (CGE) are inversely proportional to temperature. It was also observed that the use of air as gasifying agent allows higher calorific veils, and higher efficiencies were reported for the torrefied samples. The success of the sample is represented by the higher percentage. Likewise, hydrogen production were more advantageous with the raw feedstocks and steam atmosphere during gasification. In conclusion, LHV of syngas decreases with the increase of temperature in all atmospheres. CGE is obtained in the atmosphere with air, and as steam is introduced, the smaller the values. The evaluation of possible hazardous emissions mitigation and technical environmental assessment is recommended. This research was supported by CNPq, DPI, DPG, and FAPDF. Thank you all for listening.